Hello, my name is Claudia Kemp, and this is my Zoom report for the Module 4 exam for Math for Teachers. Anyways, let's get started. Number 1 asks that using these pattern blocks that we find 4 sets of fractions having 3 fractions in each set, and let each pattern block be the base for each set. So, using the hexagon as the base first, the trapezoid would represent 1/2 of the hexagon. The triangle would represent 1/6 of the hexagon. And the rhombus would represent 1/3 of the hexagon. Using the trapezoid as the base, the hexagon represents 2 whole trapezoids. The triangle represents 1/3 of the trapezoid, and the rhombus represents 2/3 of the trapezoid. Can't see that very well in the scanned document, but it's these two right here, or these two right here. Using the triangle as the base, the hexagon represents 6 whole triangles. The trapezoid represents 3 whole triangles, and the rhombus represents 2 whole triangles. And then finally, using the rhombus as the base, the hexagon represents 3 rhombuses. The trapezoid represents 3 halves, so 1 whole and 1/2. And then the triangle represents 1/2 of the rhombus. And that is how we would solve number 1. Number 2 is a word problem. I'm going to read the word problem to you first. The word problem says, a man bought a length of rope at the hardware store. He used 1/3 of the rope to make a bow painter for his canoe and then used 1/4 of the remaining piece to tie up a roll of carpet. He now has 36 feet of rope left. What was the length of rope he had originally purchased? So I've drawn it out here. We have this length of rope, and then we took 1/3 of it away to use for the bow painter. And then out of this remaining portion here, these 2/3, we took 1/4 to tie up a carpet. And now this remaining portion, after getting rid of the 1/3 and the 1/4, we have 36 feet left. So I've written over here that once the 1/4 has been removed, we know that the 1/4 was taken from 2/3 because we took 1/3 of the whole rope. That leaves 2/3. Well, we took 1/4 of those 2/3. Now we need to know what this 1/4 represents out of the entire thing. So we would multiply the 1/4 by 2/3 because we took 1/4 of, which means to multiply, 2/3, which equals 2/12, which simplified equals 1/6. And then moving down. So we now know that the 1/4 that is taken is 1/6 of the original rope. So then we would add the 1/3 that was taken earlier. So we can see we did that here. You make 1/3 into 2/6. 2/6 plus 1/6 equals 3/6, which equals 1/2. So in total, 1/2 was taken from the original piece. We know that the second half that's left over is 36 feet. So we would multiply that by 2 because it's only half of the whole, and we would get 72 feet of rope, which was the original piece that he purchased. Number 3 is equations involving fractions, and they are to be solved with number lines and fraction strip models. So the first step that would be taken is finding the least common denominator, which between 3 and 2 would be 6. So you would simplify this equation, and it would be 2/6 plus 3/6 equals 5/6. You can see here, you just jump. You jump 2/6, 1, 2, and then you jump 3/6, and you end up at 5/6. That's how you would do the number line. And then the strip model, you don't do the common denominator until at the bottom. So you would keep the 1/3, keep the 1/2, and then it equals 5/6. And then you would do the same for B through C. B, it's 1/2 plus 3/4. So you would take the 1/2, making it 2/4 plus 3/4, which equals 5/4. So you would take the 1 2/4 and then add 1 2 3/4, landing you at 5/4. And then the strip has been done here. Since it's 5/4, you would have 1 whole strip plus 1/4 of another strip. And the same is done for C and D. And then that is explained below here. Now, number 4 is a similar problem, but it's multiplication problems, and they are asking that you solve the multiplication problems using these circle diagrams and a number line diagram. So in order to use the circle diagrams, you would take however many circles that the fraction is being multiplied by. So since 1/5 is being multiplied by 3 whole, you would take 3 circles. And so it is 1/5 that's being divided. So we take this 5, the denominator, and divide every circle into 5 equal parts. And since it's only 1/5 3 times, we circle in 1 each time. So now we have 1/5 3 times, and you add those together equaling 3/5. A great visual. Then we also have a number line, 0 to 1. It was cut out in the scanner. That's my apologies. But we have 1/5, 2/5, 3/5, and it lands at 3/5. Same as done B through C. I'll do B with you. 3 times 2/4. So since we're multiplying by 3, we need 3 circles. And then we're going to split the circles into 4 equal parts, as shown here. And then in each circle, we're only going to fill in 2 portions of the 4 portions. So we have 1, 2, 1, 2, 1, 2. And so now we have 2, 4, 6 fourths, which you can see here takes 1 whole circle and then half of another, 1 1/2. You can see here we jumped 2/4 3 times. So 1, 2, 3, landing us at 6/4. 1, 2, 3, 4, 5, 6, just like that. And then that is C is done just like that, and it is explained below. Number 5 is a bit complicated, but it's a good visual. You have this square here that's divided up. It's a lot more even on the printed paper, but I did my best. And it wants to know what each letter represents in the whole. So A represents 1/4, and that's drawn out here. B also represents 1/4. C, however, represents 1/16, which you can see here the square is divided into 16ths, and that is one of them. D represents 2/16 or 1/8, and that's drawn below. E represents 1/16, and F represents 2/16. G represents 2/16 as well. And so each one of those is drawn out and colored in to show, and then also explained a little bit about below. Now the final one is number 6. It's a real-world application word problem. And this problem, you are taking a recipe for 16 brownies and turning it into a recipe for 12 brownies. So in order to do this, we have to know what part of 16 is 12. So you would take 12 and divide it by 16, which equals 0.75 or 3/4. So since 12 is 3/4 of 16, we would take each measurement of an ingredient in the original recipe and multiply it by 3/4 to go from 16 brownies to 12. So 1/3 cup of butter times 3/4 equals 1/4 cup of butter. 3 ounces of chocolate times 3/4 equals 9/4, or 2 1/4. 3/4 cup of sugar times 3/4 equals 9/16, and so on. And then the new recipe is written below and the instructions written to the side. I hope you enjoyed that video and that everything is shown clearly. Thank you for watching. If I can turn off.